Hello everyone, how are you? This is your Imtiaz Parvej sir. Welcome to my online class organized by Cantonment Public School and College Saidpur. Today we'll discuss diffusion and effusion, which belongs to chapter 2 in your chemistry book. So before starting the diffusion and effusions, I would like to give you some example. I think many of you use body spray or perfume. What will happen if you put a body spray bottle in the corner of a room with open lid? You will see that after some times the fragrance of the body spray will spread all over the room. That means the particles of the body spray spread in the rooms. This process is known as diffusion. I will give you another example. Have a look. Let's take a glass of water and add some potassium permanganate solution. Potassium permanganate, we know it's pink color. The color of the potassium permanganate is pink. If you add 2 or 3 pieces of potassium permanganate crystal, then the color of the solution will turn pink. And if you have a close look on the solution, you will see that the intensity of color in the solution is same in upper layer and also in lower layer. That means the potassium permanganate dissolve in water homogeneously. We can also make another examples of experiment. Instead of potassium permanganate, if you use the sugar, 1 or 2 tablespoon sugar, if you add the solution, and no need to stir it, just keep it. Then at first the sugar will precipitate on the bottom of the glass. After a long time later, you will see that the sugar will dissolve in the solution. When sugar dissolve in the solution, then what will happen? The solution will turn sweet. When you taste from some solution from upper part and some solution from lower part, you will see that the sweetness, intensity of sweetness is same in the lower part and also in the upper part. That means the sugar is also dissolved in water in a homogeneous way. So from these types of examples, we can give the definition of diffusion. So according to the definition of diffusion, diffusion is the process where solid, liquid or gaseous substance can spread spontaneously and homogeneously in any medium. That means spread out of any substance in any medium is called diffusion. But the process must be spontaneous and no pressure is applicable in that case. The diffusion can be depend on two things. One is temperature and another is the molecular mass of the substance. So first of all, I would like to describe the effect of temperature and then molecular mass. Have a look. In that case, if you add the sugar in a cold water, 1 spoon sugar in cold water, and no need to stir it, just keep it. You will see after some times the sugar will dissolve in the solution. That means when sugar dissolves in the solution, the process is very slow. It will take some time, but if we apply some heat, just apply some heat, that means when the temperature of the solution increase, then the process will happen rapidly. That means sugar will dissolve rapidly. So in cold water, sugar will dissolve slowly, and in warm water, the sugar will dissolve rapidly. That means the diffusion rate, this process is the diffusion, and the diffusion rate depends on temperature. When we increase the temperature, a rate of diffusion is increased. Okay. Diffusion can be happen in case of solid, liquid or gaseous substance, and during the diffusion process, the particles go from a high concentration region to low concentration region, but in absence of pressure. No pressure is applicable here. When diffusion happens, the particles move from a higher concentration to a lower concentration region. Have a look. Take the glass of water, the first example, and when you add the potassium permanganate, we know potassium permanganate, when added water, the color of the water will be pink. When the potassium permanganate is here, you will see that the intensity of color at the very first time, intensity of color in the bottom part will be the high and intensity of color in the upper part is low. That means the pink color in the bottom will be the deep and in the top it will be the light one. But after some times later you will see that the intensity of color will same in all the solution. So how this happen? When the potassium permanganate piece is added in the water, it will go to the bottom of the glass, and here the potassium permanganate molecules concentration is higher and in the upper side the concentration is lower. So potassium permanganate molecule will go from high concentration region to a lower concentration region, and this process will continue until the concentrations of the particles are not same in everywhere. Okay, when the concentrations are everywhere same, then the process will stop. Okay, so during the diffusion process, the particles will move from a concentration of high region to a concentration of lower region. Okay, this thing also can be explained in case of a gaseous substance. When we put the perfume bottle in the corner of the room with open lid, then the perfume came out. This is the room, and we put the perfume bottle in the corner of the room, then the perfume came out. Near the bottle the concentration of perfume is higher, and in the far away the concentration of perfume is lower. So in that case what happened, the perfume molecule from high concentration region go to low concentration region. Okay, and in that case no pressure is needed. This process is known as diffusion. And another thing is that the diffusion rate depends on the molecular mass. If the molecular mass is high, then the diffusion rate is low, and if molecular mass is low, then diffusion rate is high. This thing can be explained very easily with the help of an experiment. Let we take a narrow test tube, glass tube, it's transparent. Okay, fill 1 inch with a cotton wet by hydrochloric acid solution, HCl, and another end with cotton wet by ammonium hydroxide solution. We know hydrochloric acid solution will give hydrogen chloride gas and ammonium hydroxide solution will give ammonia gas. The hydrogen chloride gas and ammonia gas both will diffuse. They will travel, and where they meet there will be a reaction. This reaction is the neutralization reaction, because we know hydrogen chloride gas is an acidic substance and ammonia is a basic substance. Ammonia is basic. Why? Because ammonia has a lone pair electron. We know the substance which can donate a pair of electron is called base according to Lewis concept. So this is base and this is acid. When acid and base react, then what will happen? A neutralization reaction happen, and during neutralization reaction we know salt produced. So here the salt will be ammonium chloride. The color of ammonium chloride is white. So where hydrogen chloride and ammonia gas meet, this reaction will happen and white smoke will produce, and we can see the white smoke from outside of the tube because the tube is transparent. Okay, so an interesting thing is that the white smoke will not produce at the center of the tube, at the middle of the tube. Rather it will produce in the hydrogen chloride end. Okay, near hydrogen chloride end. Let the white smoke is produced here. Why this happen? At the same time hydrogen chloride travel this distance and ammonia gas travel that distance. That means ammonia gas travel more distance than hydrogen chloride. That means the diffusion rate of hydrogen chloride is lower than ammonia gas. Why? This can be explained with the help of Graham's diffusion law. According to Graham's diffusion law, if the molecular mass of a substance is m, and the diffusion rate of the substance is r. There is a relation between the diffusion rate and molecular mass. The relation is diffusion rate is inversely proportional to the square root of the molecular mass of the substance. That means if the molecular mass increase, then diffusion rate decrease, and if the molecular mass decrease, diffusion rate increase. We have two gas, one is hydrogen chloride and another is ammonia. Okay, the mass of hydrogen chloride is 36. We know hydrogen is 1 and chlorine is 35.5, so total is 36.5, and ammonia is 17, nitrogen 14 and hydrogen 1, 3 hydrogen 3, so 14 and 3, 17. We see that ammonia gas has lower atomic mass, molecular mass, and hydrogen chloride have a higher molecular mass. Due to lower molecular mass, ammonia gas will travel more. That means the diffusion rate of ammonia gas will be higher than hydrogen chloride gas due to this equation. And that's why the white smoke produced near the hydrogen chloride end. We have two end. One is hydrogen chloride end, another is ammonia end. We see that hydrogen chloride have higher mass than ammonia. That's why the hydrogen chloride will not travel more than ammonia. So ammonia will travel more and hydrogen chloride will travel less because its diffusion rate is low, and white smoke will produce here. And effusion. What is happen in effusion? So before give the definition of effusion, I would like to share you with an examples with an experiment. We'll take a balloon full of air, then stick a scotch tape on the balloon and make a hole here. If we make a hole, then we'll see that what happened. The air from inside the balloon will go outside with a force. This process is known as effusion. When the gaseous particle move from a high pressure region to a low pressure region through a fine pore, this process is known effusion. Effusion happens in presence of pressure. Inside the balloon, the pressure of the air is high, and outside the balloon, the pressure of the air is low. That's why the substance, that means the gaseous substance, go from a high pressure region to a low pressure region through a fine pore. This process is known as effusion. There are so much examples of effusion. When jackfruits ripen, we can feel the smell. How the smell came from the jackfruits to our nose? Actually, in jackfruits there are very small pores present. Okay, when jackfruits ripen, the smell, that means the fragrance from the jackfruits, go outside, from inside to outside, because inside the pressure of the gas is high and outside the pressure of the gas is low. So for the effusion process, the smell will go outside from the jackfruit through the small pores. We know the every substance contain small pores on their surface. Okay, also in our body skin we have also some pores. Okay, so when the smell go out, then it diffuse everywhere and we can feel the smell. So between diffusion and effusion there are some relation, some similarities and some dissimilarities. The dissimilarities is very important, and the dissimilarities, that means the differences between the diffusion and effusion, can come in the exam. So if the differences asked for the exam, first of all we will give the definition of diffusion. We know the definition of diffusion is the spread of solid, liquid or gaseous substance in any medium uniformly and spontaneously. And effusion is the passage of gases from a high pressure region to a low pressure region through a fine pore. Okay, diffusion can happen for solid, liquid or gaseous substance, but effusion can happen only for the gaseous substance. In case of diffusion, pressure is not applicable, no pressure is needed. But in case of effusion, pressure difference must be present. If the pressure difference are not present, then effusion will not happen, it will diffuse, diffusion will happen. Okay. There are also some examples of effusion which we use in our daily life. Many of you have the cylinder for cooking. Inside the cylinder, the gas are in the high pressure, and there are a small pore. Through the pore, the high pressure region, gas came out for cooking. Okay, through the small pore. So this process is the effusion. Among the diffusion and effusion first happen, then diffusion happen. First effusion happen. Let in the body spray. Let this is the body spray. Okay, in the body spray, the gaseous particles are in the high pressure inside the body spray, high pressure, and if the lid is open, then what will happen? The high pressure regions gas can come out in the low pressure region. So this process is effusion, and after effusion, the body spray can move everywhere. That means if you keep it in the corner of a room, it will take the whole place of the room. That means if diffusion happen. So first effusion happen, first then diffusion happen. So these are the basic things of diffusion and effusion. And if you have a further query, you can call me or contact me through WhatsApp or mobile. I am available at 24/7. So till then, have a good day. Thank you.